All right, everybody, we made it to our last video of topic 2. And look how fun this looks. We're going to apply a linear quadratic system. So we've got a situation to learn about. Andrew kicks a ball up a hill for his dog. Oh, Leica? How'd you guys say that? Laika? I'm going to say Leica. It's just a little bit easier, but let me know if I'm saying that wrong. So Andrew's going to kick a ball up a hill for his dog Leica to chase. The hill is modeled by a line through the origin. So I can see this blue line. It's going up the hill. It's being modeled by that blue line. The path of the ball is modeled by the quadratic function shown. So he is kicking the ball. It's going way up in the air and it comes back down. We can see right here is where it's landing on the hill, but they just kind of drew the whole parabola for us. How far does the ball travel horizontally? How far must Leica run up the hill to catch it? Okay, so the horizontal distance is our x value. We want to know what is the horizontal distance that the ball is traveling? Well, the ball travels. Here's where it hits the hill. So what is that horizontal distance? If I just kind of go straight down from here to where the ball got kicked, that's what that's looking for. So basically the x value of that intersection point. And then how far must Leica run up the hill to catch it? So we want to know what this distance is right here. So we've got a few things to figure out. We are going to create a linear quadratic system. Our linear function was y equals 0.5x. And our quadratic function was y equals negative 0.5x squared plus 6x. To find the intersection point, this is really the one we want. This one I'm assuming is 0, 0. I guess we'll find out. But we want this intersection point. So we're going to solve our linear quadratic system. We saw, in our last video how to solve a system using substitution. So that's what we're going to do. You need a y equals or an x equals. We have two y equals. So I'm just going to focus on, I know that y is equal to a 0.5x. We substitute it into the other equation for the y. So it's going to go right there. So I'm going to replace the y with 0.5x equals negative 0.5x squared plus 6x. To solve this quadratic equation, I'm going to get everything on the same side. So I want to subtract 0.5x from both sides. So we have 0 equals negative 0.5x squared, and then 6 minus a 0.5 is a positive 5.5x. All right, so we have all these decimals. This leading term is negative. We could plug into the quadratic formula. Our a value is negative 0.5, our b value is 5.5, our c value would be 0. Or I'm going to think about factoring. I mean, for me, factoring is faster. It takes a little longer to explain it in a video, but it's just a quick process. And I think that it's always good to go back and review the methods we learned earlier in the chapter. So in order to factor, here's the thing. I don't like this negative 0.5. I know that a 0.5 can divide out of this 5.5. So because we're solving the equation, I'm just going to divide everything by that negative 0.5. Every single term. 0 divided by a negative 0.5 is 0, so that's good. Negative 0.5 divided by negative 0.5 leaves us with just the x squared. And then we've got a positive divided by a negative, so it's going to be negative. And then 5.5 divided by 0.5. There are 11 of those 0.5s that fit in, and then the x just comes down. So we can factor. It's just going to be GCF factoring. These two have a common factor. We don't even have to worry about a third term on this. So I'm going to factor an x out. It leaves us with x minus 11. So here's my GCF of x. I took an x out of each term, left us with x minus 11. Now that it's factored, we can set each factor equal to 0. So x gets set equal to 0 and x minus 11 gets set equal to 0. Solve both equations. Well, the first one is already solved. There we go. And the second one, we will just add 11 to both sides, and we get 11. So what this tells me is the intersection point, or the x value of our two intersection points of the parabola and the straight line. So one intersection point has a 0 for the x, the other one has an 11 for the x. We're going to plug those into one of the equations, whichever one looks easier. That y equals 0.5x to me is the easier equation to use. You'll probably always find the linear equation is easier to plug back into. So let's plug in x equals 0 for the x. So here, I'll do this over here. When x equals 0, what's our y value? So y equals 0.5 times 0, and we just get a 0. So 0, 0. And then what if the y, or the x, is equal to 11? What's the y that goes with that? So y equals 0.5 times 11, and that gives us 5.5. So that is the other, gives us the other intersection point. So let's take a look at what we have. Right now, we know that, sorry, I'm readjusting as I'm trying to talk, too much to focus on. Our intersection point of 0, 0, that's right here. The question is asking, how far does the ball travel horizontally? So the ball travels and lands. I want to know this horizontal distance. Well, that is the x value of this intersection point. That intersection point is 11, 5.5. So we just figured out that the ball travels 5.5 feet. I'm sorry, 11 feet is the x value. That's the distance the ball travels. Well, travels 11 feet horizontally when the ball lands. So if I zoom into that picture, just to make sure that's really clear, what we just figured out, from here to here, we know this ordered pair is 11, 5.5. So we went over 11, up 5.5, so that horizontal distance is 11 feet. All right, one more question. How far must Leica run up the hill to catch it? So this is an interesting question just because when's the last time we talked about distance? So here's Leica. I feel like that's a female dog. I don't know. Running up the hill. What is this distance right here? So I can see we've got a right triangle happening right there. Here's what we don't know. I'm not going to use X. I don't want to confuse that with, I'm going to call this, I'll call it D. Okay. We've got a right triangle. Do you see if all I did was I pulled this right triangle from the graph and I carried it down. These two sides of our triangle is that ordered pair, over 11, up 5.5. So we know this is 11, this is 5.5. Does anybody remember how to find the third side of a right triangle? That's right, Pythagorean theorem. So we're going to plug in 11 and 5.5 for the A and B. So 11 squared plus 5.5 squared equals D squared. We'll go ahead and square those. 11 squared is 121 plus 5.5 squared is 30.25. Let's go ahead and add those together. That's going to give us 151.25. And then we're going to square root both sides. Now, when you're square rooting to solve, you do get two answers. But because we're talking distance measurement, the negative answer won't make sense. So I just want the positive answer, which is, I'm going to round to the nearest tenth, 12.3 feet. So going up the hill to where the ball lands, that's 12.3 feet. That's how far Leica has to run up the hill to catch it.